Aging is, at least to a large extent, a byproduct of the absence of natural selection. So there are a lot of people who are relatively thin and under muscle who have diabetes, and it's because they don't have enough muscle. If you fast them and you don't restrict calories, so in other words, they're making up for when they're not eating by eating more when they are eating, no effect on longevity, zero.
We have a sponsor for this episode of Apple Finch Pudding. But before I delve into this, I want to be very clear about what this sponsorship is being used for. This sponsorship is being used to support the podcast. This means paying for subscriptions we need, maybe some editing or some other material we need to make this podcast. That being said, our sponsor for this episode is SciSummary. As researchers, we need to read a lot of papers, and more are being published every day. As a result, reading papers is becoming more or less like a full-time job, leaving us virtually with no time to do our actual jobs, which is doing research. This is where SciSummary comes in. SciSummary provides you with an AI-based summary of the papers you provide. However, SciSummary is more than just a summarizing tool. It effectively lets you chat with your papers. You can ask questions like what materials and methods are being used, but it can even provide you with insights into potential avenues for future research based on the papers you provide. If you want, you can now try out SciSummary for 1 month for free. All you have to do is follow the link in the description below or type in scisummary.com/AFP1 and use the coupon code AFP1. AFP stands for Apple Finch Pudding, 1 because you get 1 month of SciSummary for free. Try it out. If you like it, please go for it. If you don't, no hard feelings. But for now, let's go back to the show. Welcome to Apple Finch Pudding, your gateway into the world of science. Today's scientist is Matt Kaeberlein, a professor of oral health sciences at the University of Washington. His work focuses on biological mechanisms that promote healthspan and quality of life. Welcome, Matt.
Thank you. It's a pleasure to be here.
Before we delve more into today's topic, do you have a fun science fact for our listeners?
Yeah, sure. So I think one thing that a lot of people don't realize is this relationship between body size and longevity. So longevity is, the science that I study. So there's an interesting relationship here. If you look across animals, and this is true pretty much across the entire animal kingdom, big animals tend to live longer and age slower than small animals, at least at the species level. So when you look across many different species going from, like mice to dogs to people to whales, right? Big animals tend to live longer. But when you look within species, so all humans or all dogs or all mice, big animals tend to age faster. And people know this with dogs, right? Big dogs tend to age faster than small dogs, but that seems to be true in other animals as well. So there's this interesting inverse relationship between body size and rate of aging or longevity that is different across the animal kingdom and within species.
And do we know why that is? Because it's remarkably different.
Yeah. So I would say we have pretty solid understanding of the reason why within the same species, bigger individuals tend to age faster. And it has to do with growth signaling pathway, probably best known by the growth factor IGF-1 or insulin-like growth factor 1. So again, we look at dogs, the IGF-1 gene is the greatest genetic component of body size. So higher IGF-1 signaling, bigger body size, shorter lifespan. Interestingly, that's exactly the same gene that Cynthia Kenyon pulled out in 1994 in worms as a gene that can double the lifespan of worms. And so we now know in mice, if you turn down IGF-1 signaling, you get slower aging, increased lifespan. There's even some evidence in people. And again, the biology gets a little bit complicated, but IGF-1 is connected to growth hormone. And in people who have mutations that reduce growth hormone signaling, there's evidence that they are at lower risk for a whole bunch of different age-related diseases. So again, that's probably at least partly the explanation for the relationship between body size and aging within species. Cross species, the real answer is we don't know. And there are some interesting evolutionary explanations. So one, this is not mechanistic, but it's evolutionary. One evolutionary explanation is that animals with larger body size tend to both reproduce later in life. So they have to age slowly enough that they get to reproductive age to pass their genes on to the next generation. So evolution has sort of forced that to happen. They also have to be protected against cancer. They tend to have a lot more cells. Bigger body size means more cells, means higher likelihood of developing mutations that can lead to cancer. So larger animals tend to have more potent anti-cancer mechanisms. That may also be part of the explanation for why they live longer.
You've already talked now about aging, but maybe to start with the basics, and this is an easy question, but probably difficult to answer. What is biological aging?
It is a difficult question to answer in some ways. I think mostly because we understand what aging is conceptually. But when, in science, of course, we like to give very detailed definitions that are measurable and quantitative. And it's funny because I just returned from a couple of conferences, one of which was this first gerophysics conference. So that's the intersection of aging biology, which is geroscience, and physics. And that was kind of one of the questions that came out. Like, what do we even mean when we talk about biological aging and how do we measure it? So I think there are a few definitions, a couple that I tend to come back to when we're talking from a scientific perspective about what is biological aging. One is the loss of a biological system's ability to return to homeostasis or normal function. So biological systems are being perturbed all the time. Our bodies are constantly exposed to different types of stresses that can move us out of optimal function. And one of the hallmarks that is always true in every animal as they get older is the loss of that ability when perturbed to return to optimal function or normal function. So failure to maintain homeostasis, which is, again, thinking about this from a physics perspective, associated with an increase in entropy over time. So that could be another sort of definition of aging. And so that's one conceptual way to think about biological aging. Another way to think about it, these are not mutually exclusive at all, is biological aging is the accumulation of damage. And there are many different types of damage that can accumulate at the cellular, intracellular, tissue, organ levels that lead to declines in function and an increased risk of a variety of different age-related diseases and eventually mortality. And so there are many factors that are involved in why we see increases in damage with age, but at a very simplistic level, one is the production of damage, all of the different things that our bodies are exposed to in the environment, internally from, metabolic reactions, and the decline in the ability of our cells to repair that damage or degrade the damage. So the accumulation of damage over time that leads to dysfunction at all of these different levels of complexity.
Accumulation of damage over time is basically what causes aging. And as you alluded to before, like large animals want or need to live longer because their reproduction happens at a later age. Biologically speaking, does it even make sense for us to live beyond our reproductive years?
Well, so again, I think you can look at this through different lenses. Through the lens of evolution, right? Natural evolution by natural selection. I think at a minimum, we can say there is a dramatic decrease in the selective value of living beyond peak reproductive age, right? So from the perspective of natural selection, the goal is to be as effective as possible at passing your genes on to the next generation. But it's also important to appreciate not only do you have to pass your genes on, but that next generation has to be reproductively successful, right? So you could argue there is some value in certain species, and humans are probably one of them, to having the parents around for some period of time after reproduction to give the next generation the best opportunity to thrive and go on to reproduce. So there's ideas of kin selection and things like that are related to the force of natural selection acting to increase lifespan beyond reproductive years in order to provide value to the next generation. But all of that, being said, I do think there's no question that the strength of natural selection falls off dramatically after peak reproductive years. And aging, I don't think anybody would really argue with this who is an expert in the field. Aging is, at least to a large extent, a byproduct of the absence of natural selection. In other words, evolution, natural selection acts to maintain optimal function up to the point where you've done your job. And then once you've done your job, which is to ensure the success of your progeny, evolution doesn't care about you anymore. And so it's not that we are evolved to age necessarily. That's a different thing. That would be called programmed aging. We could talk about that. I don't think very many people believe that humans or most other animals have been selected to age. It's more that aging is the byproduct of the absence of natural selection to keep us working well.
So there's not a large enough incentive anymore to keep us alive, so we start aging.
That's right.
Yeah.
Yeah,
okay.
That's right. There's no reason to keep the repair systems working optimally or to continue to put, resources into an individual who has already done their job from a selective perspective.
And there's also a big difference in focus between actually lifespan and health span. I think the focus is more on health span. Can you explain a bit more what is meant by that?
It depends on the context that you're referring to. So I think in the basic science world, both are studied pretty extensively because I think they may tell you somewhat different things about the mechanisms of biological aging. So again, maybe we start with definitions. So lifespan is very straightforward, right? Lifespan is the length of time from birth till death. No ambiguity there. Health span is a little bit more of a concept and not so much of a quantitative variable. And what I mean by that is that, conceptually, I think we all understand the idea that health declines with age. There is a period of life that is spent in high function, relatively good health. At some point, that health declines below a threshold where it's no longer considered good function. The problem is we don't know exactly, there's no single definition of what that threshold is. So the problem with health span as a word is it implies that we can measure it, like that, we go from having health span one day and it ends the next day. That's not the situation. So I think as a concept, though, it's useful to appreciate health declines with age. There are other things that can cause health to decline beyond aging, but certainly with age, health declines. And the idea is to maximize health span, is to really push the diseases and functional declines of aging out as late as possible, get the health span curve, so to speak, as close to the lifespan curve as we can. And a concept that is related to this is something called compression of morbidity. What that means is morbidity is just diseases of aging. We want to compress those diseases of aging as late into life as we can so that the minimum amount of time is spent in a disease dysfunctional state. But I do think it's important to clarify. I think the push to emphasize health span is more from the perspective of clinical translational perspective, so what we can do in humans, than it is really the basic biology of aging. And one interesting question is, to what extent are health span and lifespan able to be dissociated when we target the biology of aging? So we know lots of ways to increase lifespan, maybe not lots, at least a handful of ways to increase lifespan in laboratory animals. And when we do that, that seems to reduce the onset and progression of every age-related functional decline in disease because we've targeted the biology of aging. In fact, I think you can make a reasonable argument. It is probably impossible to significantly increase median and maximum lifespan of a population that is existing in a relatively favorable environment. It's almost impossible to significantly increase population lifespan without targeting the biology of aging. So when we do that in laboratory animals, we seem to increase health span as well. I'm not aware of a single convincing case where we have increased lifespan robustly and not also increased health span. Certainly, though, you can go the other direction and decrease health span without decreasing lifespan, right? You can live a long time in a sick state or in a state of poor health. But usually in order to do that, you need to do something beyond just accelerating biological aging, because if you accelerate biological aging, you're also going to shorten lifespan.
Well, it's at least comforting that we're talking about healthy aging.
Well, I think the other thing that's interesting here is, again, most people, I think, who have expertise in the space would agree, in people, it seems like it's going to be much easier to increase health span, at least at the population level, than it is to robustly increase lifespan. There are a variety of reasons for that. One of them being that, at least in most developed nations, people are not particularly healthy, and that comes down a lot to environment and lifestyle. But it does seem like there is some low-hanging fruit to increase health span. It may be harder to robustly increase human lifespan. That was another thing that came out of this gerophysics conference that I was at, is there seems to be growing consensus that in humans, there's a barrier. We don't understand what that barrier is at this point, but there seems to be a barrier around 110 to 130 years. There's some wiggle room in what that is, that all of the things we're studying right now seem to be getting us closer to that barrier, but may not help us get past that barrier. So it might be more feasible, at least given what we know now, to move Healthspan out, to where a lot of people can get into their 90s, maybe even their early hundreds in relatively good health. But to push lifespan out much beyond that may be a much heavier lift.
We don't have an idea why that is right now.
We have some ideas from a conceptual level, but not from a mechanistic level. I think that's fair to say. And there's a lot we don't understand about the biology of aging.
Yeah, because also people age at different rates. Some of those things are environmental. For example, people who smoke versus people who don't smoke. But even if people are living healthy, assuming people are doing what they can, they still age at a different rate. Why is that?
Well, so again, one sort of simple answer, and I'll do better than this in a minute, but it's useful for people to appreciate, rate of aging is a biological trait, right? It's driven by biological processes. And every biological trait is a combination of genetics and environment. So there is going to be a genetic component and there is going to be an environmental component to every trait. Different traits have different ratios of how important genetics is and how important environment is. So one interesting question is, when we talk about lifespan, it's harder to do with Healthspan because we don't have as much long-term data on Healthspan, and Healthspan isn't as quantitative. But for lifespan, people have made, I think, pretty reasonable estimates of how much of longevity, human longevity, is genetic and how much is environmental. And there are really two answers, and it depends a little bit on the way you do the math. So the sort of most talked about answer here is that human longevity is about 75% environmental and 25% genetic. That probably is an overestimate of the importance of environment and an underestimate of genetics. And the reason why the importance of genetics has been underestimated is those studies have all been done looking at people who are now 90, 100 years old, right? So over the past century, the demographics of longevity have changed a lot over the last century. And it turns out in those cohorts, there's a chunk of people who died before, say, age 50, when what's called extrinsic mortality is higher. In other words, death due to non-age-related causes, right? Famine, infectious diseases that are not age-related, things like that. So when you take those people out of the equation and you may say only look at people who live past age 50, and this is new, so I don't want to say this with 100% certainty, but the evidence seems to suggest that the role of genetics, once you make it past age 50, may be closer to like 40, 45%, maybe even 50%. So the answer is both are important, and you can't do a lot about your genetics, at least right now, maybe someday. So you should focus on what you can do something about, which is the environment. And really the environment, I think we'll see how important things like, microplastics and pollution are. They're going to be important, but most of the environmental factors that influence health span and lifespan in people are lifestyle.
If you say environment and lifestyle, is it then epigenetics?
Partly. So again, maybe just for definitional purposes, epigenetics is a term that is, I think, often confused and maybe overused or misused. So all epigenetics refer to are regulatory control of gene expression beyond the DNA sequence, right? So genetics is your DNA sequence. There are biological control points that can be put on top of your DNA sequence to control which genes get turned up, which genes get turned down, which genes get turned on and off. So that's epigenetics, just on top of the genome. And there are a variety of ways that can happen. Oftentimes, what people mean when they talk about epigenetics is DNA methylation, because that's the one that's been studied the most, but that's really only one type of epigenetic control. So yes, the environment can regulate gene expression and thereby regulate the biology of aging through epigenetic changes. But there are lots of other changes that your environment can impact your health, your physiology, your function, your longevity, independent of epigenetics. So epigenetics is part of the story. And if we look at it through the lens of these things called the hallmarks of aging, which are just, like conserved mechanisms or aspects of biological aging. Epigenetic dysregulation is one of about 12. So it's not everything, but it's part of the story.
And if you then talk about environment and daily habits, I'm curious actually, what are some of the daily habits that you maintain for your health and to age well, let's say it like that?
So I really think about lifestyle through the lens of 4 pillars of health. And, everybody's got their pillars of health, and that's fine. I like these 4. This is what we use at my company, Optispan. And we like active words. So we go with eat, move, sleep, connect. Okay. So eat, of course, is nutrition. Move is regular exercise. Sleep is self-evident, sleep quality. And connect includes both sort of your personal connection to the world around you. Some people would call that mindfulness, and human connection, right? Our relationships with other people or even companion animals. And sort of woven through all of those pillars is the role of stress in our sort of health in our daily life. So we don't put stress into its own pillar because that really is impacted by all of the pillars. So that's the way I think about lifestyle. And then I have my own personal strategies within each of those, which I'm happy to share. But, there's no real magic here. I think I tend to be pretty pragmatic. I'm certainly not one of those people who tries to over-engineer everything. And what I mean by that is I think, we don't really have a great understanding of what optimal is. I think we want to try to get to optimal, but we don't actually know what that is. And so we can spend a lot of time coming up with very, very detailed, protocols or whatever to try to get to optimal. And I think pretty quick, once you get past the basics, you reach a point of diminishing returns where it can actually become counterproductive to try to over-engineer your lifestyle. At least that's my personal approach. So when it comes to diet, I have, and again, I'm learning as I go. So I certainly don't want to suggest that I've got everything dialed in, but I've made a lot of changes in the last, 5 or 6 years. So I tend to start from the principle that I want to get as much of my nutrition in the form of whole foods. So generally avoid highly processed foods. I have become almost religious at reading labels and looking for added sugars. Everybody should do that. If you don't do it now, you will be shocked at the food companies put in our food. It's ridiculous. You want to try to avoid added sugars as much as you possibly can. So that's something I do. I really, again, I'm sure people have heard this, but it absolutely works, at least in the United States. I'd be interested to hear from you if the grocery stores are laid out the same way where you're at. But in the United States, shop around the edge of the grocery store. That's where all the good stuff is. Don't go down the aisles because that's where all the bad stuff is. Other than, I think it's okay to go down the coffee aisle. I'm a coffee person. And maybe frozen fruits and vegetables. You really don't need to be in those other aisles very often. Maybe spices for cooking, olive oil, stuff like that. But really focus on good quality foods. I don't worry too much about, so if you think about it in the perspective of, you can think about food like what you eat, when you eat, and how much you eat, right? So I kind of put how much you eat and what you eat as really, really important. And I don't personally worry about when you eat. I know there's a lot of people who are into time restricted eating or intermittent fasting. I think those can be useful strategies if they help you control how much you eat. But there's not a lot of evidence that restricting your eating window independent of how much you eat and what you eat has a big impact for most people. So if it's useful, great. But I think really focusing on what you eat and how much you eat. And so what does that mean, how much you eat? That's going to be different for everybody. So I think the whole food, avoid highly processed foods, that is generally going to be the correct answer for most people, if not everyone. But how much you eat is going to be very individual, and it depends on your own genetics, your own activity level. So I would guide to body composition as a good way to assess if you are overfed or underfed, right? And so that also is connected to exercise or the move pillar. So that's kind of the way I think about eat. I would also put under eat, empty calories and alcohol. So, again, I'm not one of those people who says, don't drink any alcohol ever. I drink, a couple times a month, maybe. I cut way back on the amount of alcohol I consume. I think in general, alcohol is not helpful for most people, and it can be harmful for lots of people. So really pay attention to alcohol and keep it limited. But certainly if you want to go out and have drinks with friends once in a while, great, go do that. Protein is the other one that a lot of people ask about. I don't think we actually know what the answer is for what is optimal protein. Again, that's probably going to be somewhat individual. It's definitely going to depend on the quality of the diet you're eating and how active you are. I tend to eat what would be considered a pretty high protein diet. Some people are concerned about high protein because it can increase IGF-1, which we talked about earlier. Some people are worried that that might be pro-cancer. I think the evidence linking high protein to higher risk of cancer is exclusively found in populations that are eating a low quality diet and are overweight and obese. I don't believe that there is any real cancer risk from a high protein diet if you're eating a healthy diet and you're not overfed. So that's my own personal view. And I think that maintaining muscle mass is really, really important as we get older. So if you are practicing resistance training regularly, I think a relatively high protein diet can help. And I personally find protein to be satiating. And so I'm not hungry all the time, which is you don't want to be hungry all the time. That makes it hard to eat an optimal diet. So anyways, that's my thoughts on eat. Exercise, just do it, right? Again, you can spend a lot of time worrying about what is optimal. Like, I think you want to get out and move every single day as a starting point. If it's helpful to have like step counts or whatever, great, that's a goal. I think next level, which is probably where everybody should strive to get to pretty quickly, is a mix of resistance training and what's considered cardiovascular training, right? And I think there are lots of things that can go in either of those buckets. So I don't tend to get too prescriptive. I think you have to really find what works for you. So what works for me is, I live in Seattle, so we have kind of gray winters, right? But when it's not rainy or when the weather's cooperating, my wife and I like to get outside and hike. That's a great way to get cardiovascular exercise. You're outside, you're in the sun, but that works for us. It may not work for everybody. And when I can't do that, I tend to get up early in the morning. I'm usually up by 4:30, and I do 30 minutes on the elliptical trainer. And then probably 4 times a week, I do weightlifting. And I like to use free weights. I think for me, that is really the best way to go. You can use body weight exercises. You can use machines. Doesn't matter. You just need to lift weight with your muscles and work your muscles out to build lean mass when you can and maintain lean mass as you get older and maintain bone density. So a lot of people underappreciate the importance of maintaining bone density and lean mass. There's a bunch of reasons. There's the obvious one, which is that if you fall down, you don't want to break a bone. You want to be able to get back up. If you don't have enough muscle and you have low bone mass, you're going to break a bone and you won't be able to get back up. You don't want that to happen. There's also the metabolic component, though. So a lot of people don't realize that muscle is one of our most potent defense mechanisms against metabolic disease and diabetes. And so the more muscle you have, in general, the better off you're going to be from a metabolic perspective. The more muscle and the lower what's called visceral adipose, so fat around your internal organs, the better off you're going to be from a metabolic perspective. So there are a lot of people who are relatively thin and under-muscled who have diabetes, and it's because they don't have enough muscle. So that's something you want to be aware of as well. And it's harder to maintain muscle as we get older. So the better off you can be in your 50s, 60s, 70s, the better off you're going to be later on down the road. Sleep, again, that is pretty self-evident. I'm lucky. I don't have a lot of challenges around sleep, so I haven't had to do a lot in terms of sleep hygiene to get good quality sleep. But there are well-documented strategies that people can take if you struggle with sleep. Depending on your personality, I think sleep trackers, just like activity trackers, can be valuable. But if they cause you stress and keep you from getting good sleep, then it's probably not a good strategy to improve your sleep by wearing an Oura ring or whatever. So, the kinds of things that are sort of obvious around sleep hygiene are, reducing your exposure to screens near bedtime, reducing food and alcohol consumption. Alcohol is the great killer of sleep quality. I think anybody who's ever worn a sleep tracker and consumed alcohol has probably had that experience. So just be aware again, if you're drinking around bedtime, it is very likely that it's going to have a negative impact on your sleep quality. And then trying to reduce stress. I think strategies around mindfulness can have a big impact on sleep quality as well. And then the last one is connect. Again, there are a variety of strategies around connecting with your personal world around you. Again, I'm going to put that under the bucket of mindfulness or things like breathing strategies. And then I think there's the human relationship part. And again, for me personally, that's, I think, one that I have made a dedicated effort to strengthen my relationships with other human beings, I think, especially men, we tend to sometimes, going into middle age, fall into a trap where we don't nourish those relationships, and we tend to be lonely sometimes. And I think if you're lucky like I am, and you've got a really fantastic wife, you've got that really strong relationship. But I think we often tend to let the other relationships in our lives lose strength. And so it's really important just to have those relationships. And so that's something that I personally tried to work on. So all of that, I think encompasses my strategy. I know that was a long answer, but hopefully it was, informative, at least from my perspective, as to what I do. That's kind of the way I approach lifestyle, recognizing that it is an ongoing learning process. And my goal is to continue to get closer to optimal health span, recognizing that I'll probably never make it too optimal because we don't really know what optimal is.
That was a very interesting answer. It gave me a lot of insights. I also took some notes. For example, you said to avoid sugar. We all know sugar is bad, but why is it bad in terms of aging?
Well, let me say a couple things there. I said avoid added sugars. So
Yes.
I don't want to get in. I don't want to confuse people into thinking that sugar, period, is bad, right? There are all sorts of natural sugars. Vegetables have sugars. Some fruits have a lot of sugar. And I think there are questions around, at least if you are already metabolically perturbed, pre-diabetic, for example, the fruits that are very high in simple sugar may not be a good choice for you. So things like bananas that will spike your glucose. So I'm specifically saying watch for foods where the food companies have added sugars. And those sugars can come in a variety of forms, but in general, they are paired with fat. And so there's a couple of problems there. One is metabolically, that has an impact on your body where over time it will degrade insulin sensitivity. So your body's ability to respond appropriately when it's presented with a lot of dietary sugar all at once, that gets into your bloodstream. Our bodies secrete insulin to pull the sugar out of our bloodstream. That's where muscle also becomes really important, because a lot of that sugar will go into muscle. So over time, if you're eating a lot of foods that are high in simple sugar and high in fat, your body will become resistant to the insulin itself. And so it won't be able to clear that sugar from your bloodstream. It will have to secrete more insulin. Eventually that leads to diabetes. So it will put you on a path to diabetes for sure. And that's why, again, some people might argue with this, but I think it's silly. That's why we have an epidemic of obesity and diabetes in the United States and many other countries, because of the low cost, really good tasting, terrible food that we all have access to 24/7. So anyways, that's the reason why I think you want to watch out for food. And the other piece is, those foods for most people tend to be the opposite of satiating. You actually are hungry again within an hour and a half. So you're eating that same bad food again. And what happens is your body is constantly getting too many nutrients, and it has constantly being presented with a lot of simple sugar, which leads to chronically elevated blood glucose levels. I should have mentioned this in the sort of lifestyle piece around nutrition. I think personally, continuous glucose monitoring, so the devices you can wear that will show you your blood glucose in real time for a couple of weeks. I don't think anybody should be wearing those all the time unless you're diabetic or you really find it valuable. But I think everybody can find value from going through a well-designed continuous glucose monitoring course or module. You're going to learn a lot about your body. You're going to learn about where you are metabolically today and how your body responds to different foods. And different people respond differently. And so I think it's a really useful learning tool to see what happens if I eat a banana? What happens if I eat a bagel? What happens if I have broccoli for dinner, right? And you can't unlearn it. I think that's the other power. It's a really sticky tool. When you see what that bagel does to your blood sugar, you're going to remember that every time you're presented with a bagel in the future, right? Doesn't mean you won't have the bagel, but it may make you think twice before you have the bagel or the Snicker bars or whatever, when you know what that's doing to your body. So I think CGMs, continuous glucose monitors, can be very powerful tools in that way.
Thank you for making the distinction between added sugar and normal sugar in food. But it always surprises me when we talk about maple syrup and honey. I used to think that is natural, but it's also added sugar.
That's right. Yeah. And again, I mean, I think context is really important here, right? So there are natural forms of sugar that can be added to food that then become added sugars. And again, the the sugar that you would get, even if it's the same molecule, glucose, fructose, whatever, the sugar molecule itself in the context of broccoli or asparagus or a carrot is going to be different. They're going to be different from each other, but it's also going to be different than, if you're putting maple syrup on your waffle, right? Where you're going to get this huge glucose spike, both from the waffle and from the maple syrup. It's like additive, and that's probably not a good thing.
And it also surprised me a bit that you said that you have a high protein diet, because when you check literature or I try to check some literature, and what comes back to me always is like, you need to mildly stress your body to actually promote longevity, like fasting, stuff like that, or a shortage of one protein, a little bit, not a complete shortage, but just to stress your body a little bit to promote longevity. So that's something that you don't do in terms of protein.
Right. So this is where, unfortunately, the sort of what has been propagated on the internet is not scientific. So I can tell you what the actual science says, and it's complicated. And I get that's partly why. But unfortunately, with the sort of proliferation of influencers who have never, ever done anything in the field of longevity, who suddenly are experts in longevity, you get a lot of bad information out there. So fasting is interesting. So first of all, we have to be really clear what data comes from laboratory animals, mice, rats, worms, flies, yeast in the laboratory, and what comes from humans, and what was the actual experiment that we've done. So fasting is really interesting. When you look at the data in mice, there's no question caloric restriction extends lifespan in mice and rats, at least in many different genetic backgrounds. You reduce calories down to about 60%, somewhere between a third and a half of the different mouse strains will live much longer. The other half will have no effect or live shorter. So first of all, it's not a universal, but it's really effective in those genetic backgrounds where it works. If you fast them and you don't restrict calories, so in other words, they're making up for when they're not eating by eating more when they are eating, no effect on longevity, 0. Maybe tiny, like 2%, but it's offset in the other situations where it doesn't work. So it's a net 0. So there's this whole misinformation out there that fasting is a pro-longevity. Fasting is pro-longevity if it's also caloric restriction. It's not caloric restriction, no evidence for longevity. Does that mean there are no health benefits? Not at all. This is why I said I think time-restricted eating, fasting for some people can help them maintain a healthy body weight, but it's not a pro-longevity mechanism outside of how much you eat. That's why I said, how much, what, really important, when, not really that important unless it impacts how much and what. That's what the science says. Now, you can point to studies. Here's the challenge, though, right? You can go to PubMed or the internet, and you can find one study to support any position you want to take, right? So I'm sure there are people who will listen to this and be like, but this study over here said this. Well, first you have to go read the study, actually look at what was done, ask yourself, was it done well? But you also have to have an appreciation of the whole body of literature so that you're not misled by one study where somebody had a specific point that they were trying to make so they could get their grant funding. So the body of literature is very, very clear right now. And again, I'm not saying it couldn't change in 10 years as we get more data. Right now, fasting independent of caloric consumption, no evidence for a longevity benefit, period, full stop. There's just no question there. This idea around like stressing your body a little bit and then, that you get some benefits from that, that's a concept called hormesis, the idea that a little bit of stress is beneficial. Why is it beneficial? It's beneficial because if it's the right kind of stress, you turn up the repair and stress response pathways. In other words, they get stimulated by that stress, and then that increased resistance persists for a while. So you clear more damage, you're protected against more damage. There's pretty good evidence in very simple animal models. So nematode worms, budding yeast, single-celled model, little bit in fruit flies, that you can do this in a controlled way. In other words, you can temperature shock a worm for 60 minutes, and then it will live a little bit longer from that single temperature shock. There's not a lot of evidence in mice to support that idea directly. In other words, there aren't very many experiments where people have said, we're going to go in, do a hormesis challenge and see long-term benefits. Again, it doesn't mean it doesn't exist, but there's not much evidence to support that. And I don't think there's any real evidence direct in people to support that. So it's a nice concept. it might be true, but there's not a lot of solid evidence that we should be going around trying to stress ourselves to get these protective effects. Now, where does that kind of come into the popular sort of thinking? One place is like sauna and cold plunge. And I think there is some evidence, particularly for sauna, to suggest that repeated sauna use is associated with some reasonably good health outcomes in Scandinavian countries. I'm not aware of any data in broader populations. Again, it doesn't mean it doesn't work. I'm just not aware of any data. And it's unclear whether that's through a hormesis mechanism or through some other mechanism. Social, there's a social component to sauna, at least in many of the countries where this has been studied. Potentially those people also live a healthier lifestyle. So the mechanisms and causality, I think, remain to be determined. So unfortunately, I get it. People want simple answers. It sounds great. Yeah, go, restrict your calories to 8 hours a day and do a sauna and cold plunge and you're going to live forever. That's fine, but it's not true. That's misinformation.
Yeah. Okay. Well, thank you for correcting the misinformation. One of the things that I also read was when you fast, that you get more autophagy, which is also beneficial for against aging, but maybe that's not completely true as well then.
So again, there is evidence to support the idea that autophagy can increase longevity in laboratory animals. Again, most of that comes from nematode worms and fruit flies and yeast, a little bit in mice, but not a lot direct. So, and again, conceptually, it makes sense, right? Autophagy is people call it like the cellular recycling center, right? It's a way to degrade damage that is accumulated, and we know damage accumulates with age. We already talked about that. So if you could selectively degrade the age-related damage, that would be expected to be beneficial, potentially increase lifespan and health span. Autophagy is a mechanism to do that. In very simple laboratory animals, turning up autophagy is necessary for lifespan extension from things like caloric restriction or rapamycin. We haven't talked about rapamycin yet. So rapamycin is a drug that increases autophagy and also increases lifespan in lots and lots of different animals. An interesting question is, does rapamycin increase lifespan by increasing autophagy? Maybe. Probably that's part of the story. It's not going to be the whole story. But that is kind of where the data stops. And then that gets overinterpreted into fasting is beneficial because it induces autophagy. So fasting, if you fast long enough, will in fact induce autophagy. How long you have to fast to get robust induction of autophagy is unclear in people. And in part, it's unclear because we don't have great tools to measure what's called productive autophagy. We just can't really measure it right now. So people who are saying you should fast for 16 hours because it will boost autophagy are doing a major extrapolation from what we actually know. That may or may not be correct, that you're boosting autophagy. And even if you were, that may or may not be beneficial. I think it probably would be, but there's an if there. If you don't then eat twice as much the next day to make up for fasting the day before. Because if you do eat twice as much the next day, that's going to have a negative impact that might offset the benefit of the fast. So again, it's complicated, and it really depends on the context and whether or not the fasting or time-restricted eating is also helping you to not overconsume a total number of calories that are suboptimal.
So I think the main goal is still actually caloric restriction.
I mean, this is where I think we have to be a little bit careful not to extrapolate too much from the laboratory animals, because in mice, you can go down to a caloric intake that would probably be about equivalent to, 900 calories a day or 800 calories a day for a typical person, like really, really severe caloric restriction. That's where you get the biggest impact on lifespan, at least in the genetic backgrounds that respond to caloric restriction well. I think we do know mice in the laboratory live in a very well-controlled environment. It's not sterile, but they don't get exposed to a lot of the pathogens that they would in the wild or the pathogens we experience. Temperature is really well controlled. So it's a low stress environment, I think is fair to say. I think we know if you took most people and you put them on an 800 or 900 calorie a day diet, that's going to be really challenging. There's going to be physical challenges. There's going to be emotional challenges, mental health challenges, social challenges. And I think there's a risk that because our environments are so complicated and we are exposed to a lot of pathogens, there's also going to be the likelihood of negative impact of being exposed to the pathogens, because at that very low calorie level, your immune system is not going to be functioning as well as it would if you're getting optimal calories. Other thing that's really important to appreciate is mice in the laboratory and rats, while they do see declines in bone density, they are less likely to die from the consequences of low muscle mass and low bone density because they're in this protected environment. They're in their cages 24/7. So in people, we know with age, loss of muscle mass, so frailty, and low bone density is a much greater driver of disability and death than it is in mice. If you're on a very low calorie diet, you're much, much more likely to be under muscled and have low bone density. So I would personally be concerned with recommending that type of calorie restriction. Even if it slows biological aging, it might have more than equal negative impacts on health span and lifespan for other reasons like low muscle mass and low bone density. So I think it would be a mistake for most people to try to take what seems to work in mice and apply it with respect to caloric restriction in humans. I would feel much more comfortable saying, we kind of know what is too much body weight, or at least a body composition that is under muscled and over adipose, over fat. And we know what is too low. So let's try to shoot somewhere in the middle and eat what you need to eat to get there and make it a high quality diet. I think that's a pretty solid recommendation that is going to be true. Is that optimal? Probably not, because we don't know what optimal is yet, but it's a pretty good bet for having a good quality of health span for longer than what most people are currently achieving.
I also want to emphasize something that you said. Even if you do caloric restriction, even if it's a small amount, we still need to have nutritious food.
I think that's absolutely really important. And I think it's important to explicitly say that's not just true for caloric restriction, it's true for the different sort of types of dietary approaches people may consider. You can have a very high quality vegetarian diet and you can have a really, really low quality vegetarian diet. And the impact on your health is going to be dramatically different if you're eating a low quality vegetarian diet. So that quality of food is important, independent of the sort of dietary strategy that you gravitate towards that you find works best for you.
Yeah. Sugar is vegetarian. So
right.
You already briefly mentioned rapamycin. I think we should talk a little bit about that at least. If I'm not mistaken, you have used rapamycin yourself against inflammation. I think it was frozen shoulder. Can you tell us a bit more about that?
Sure. So just to take a step back, I mentioned rapamycin in the context of it's a drug that has been shown to increase lifespan, improve health span in lots of different laboratory animals. It's an inhibitor of a protein called mTOR. mTOR actually stands for mechanistic target of rapamycin. So the protein named after the drug. The reason why I'm bringing that up is mTOR is in the same sort of network as IGF-1 and growth hormone, which we already touched on. So it is a central growth regulatory component that every cell in our bodies and every animal has. And it really helps the cell, the animal, sense the environment and make the decision, is it a good time to grow and reproduce? Or if not, is it better to be stress resistant and shut down reproduction? And one of the key things that one of the key pieces of information mTOR uses in that decision is nutrient levels. How much food is available? There's not much food in the environment. It's a really, really bad time to grow and reproduce and have babies because you don't have anything to feed them. This gets back to our evolutionary argument for aging. So calorie restriction, for example, turns down mTOR because there's not much food around. And that turns down growth and promotes stress resistance. And that's probably, at least in part, that stress resistance that accounts for increased lifespan, slower aging. Turning down mTOR also turns up autophagy, which we talked about. Why does it turn up autophagy? If there's not much food in the environment, you need to break down the excess material within your own cells to have the building blocks to build the stuff you need. So that's probably why calorie restriction turns down mTOR, increases autophagy. Okay, so rapamycin is a drug that tricks the cell into thinking that there isn't much food around. So it turns down mTOR sort of independent of the nutrient level that's available in the environment. And when you do that in laboratory animals, and this works in every animal where this has ever been tested, you increase lifespan and you seem to delay the declines or the changes that go along with aging at every level, cellular, molecular, tissue level. And in more complicated animals like mice and rats, you seem to delay many of the diseases of aging. And we could go through a long list, but almost every disease of aging you could imagine has been studied in this context. What's really interesting about rapamycin beyond that is in laboratory animals, again, I'm being very careful because we don't know in humans yet. We'll talk about humans in my experience in a second. But in laboratory animals, we know that you can start the treatment in middle age, so like the 60-year-old equivalent of a mouse, and you still seem to get most, if not all, of the benefits in terms of longevity and health span. That's really important when we think about the translational intervention we might use someday in people or in companion animals like dogs and cats. You want something you can start the treatment in middle age, not something you have to start at a very young age. The other thing that's really exciting is, at least in certain tissues and organs, you can start in middle age when there's already been a decline in function. And what I mean by that is, I think this is intuitive. If we look at many of our tissues and organs and we're 60 years old, they're not functioning as well as they were when we were 20 years old. And we can measure that in some cases. You can use an echocardiogram, for example, in the heart. That's ultrasound for the heart. And you can see a decline in function over that 40-year period. So with rapamycin, from studies in mice, we know you can start the treatment at like that 60, 65-year-old equivalent biologically. And within about 4 to 10 weeks, you can actually see restoration of function in certain tissues and organs. So again, that's been best documented in the heart, the oral cavity, where you can reverse periodontal disease, the immune system, where you can improve immune response to vaccines, the ovaries, really interesting. So in mice, ovarian function declines with age, just like in women. You can actually, at least up to some point, reverse ovarian dysfunction with age with rapamycin treatment. And in the brain, you can reverse some aspects of dementia and cognitive decline. So that's been seen in mice. So now the question is, what do we know in people, right? And of course, we don't know a lot because nobody's done the definitive randomized double-blind placebo-controlled clinical trials. So what we do know is rapamycin was FDA approved 25 some years ago for organ transplant rejection. So it's been used extensively in humans for that purpose. And so it's commonly been referred to as an immune suppressant, certainly at high doses in people and in combination with other immunosuppressants. Rapamycin is effective at preventing rejection of transplanted organs. So it does have a potent impact on the immune system. In more recent years, there's been a growing number of people who have been using rapamycin, what's called off-label. All that means is a doctor can prescribe any FDA-approved drug once it's FDA approved for any reason if they believe that it is in the best interest of their patient. And when they do that, if they're prescribing it for something other than what it is FDA approved for, that's called the label indication. It's called off-label because it's being prescribed for something other than what's on the label. So many people have started using rapamycin off-label under a doctor's supervision in most cases. And so we and others have started to try to collect data from those people. And some of us, like me, have also used rapamycin ourselves. There have also been a couple of clinical trials. Probably the best data comes from work from Joan Manick when she was at Novartis and then at Restore Bio, where they showed that a derivative of rapamycin, so it's a slightly different molecule, but it works exactly the same way, can improve flu vaccine response in healthy elderly people. Matches exactly what's been seen in mice. Okay, so what do we know? So my personal experience, and look, if you'd asked me 10 years ago, should people be using rapamycin off-label, I probably would have given sort of a hand-wavy answer. I don't think that's a good idea. We need more data. I, changed my opinion probably 5 years ago now when I was diagnosed with frozen shoulder, which is inflammation of the shoulder capsule. And it was a long, sort of painful process to get to the diagnosis. Short story is I couldn't sleep because it hurt so much. I couldn't lift weights and I couldn't throw a football with my son. That's what really got me into to finally get it fixed. And I thought I had a rotator cuff tear, but the specialist very quickly diagnosed it as just inflammation of the shoulder capsule. I'd never heard of this before, but it turns out that it's not uncommon in people in their mid 40s to early 60s to have this condition. And it's really, really painful. It's called frozen shoulder because not only do you have pain, but you lose range of motion in your shoulder. So like I said, I couldn't make that throwing motion. And so I went to saw a specialist and, he basically said, I can give you a shot of cortisone into the joint, but I don't want to do that because that can cause more problems down the road. So I want you to go back to physical therapy and it might go away in a year. That's what he said to me. It might go away in a year. And I'm like, I cannot do this for another year. So I started thinking to myself, okay, this is an age-related inflammatory condition. At the time, my lab was studying rapamycin in mice, seeing that we could reduce inflammation in the gums, inflammation in a bunch of other tissues. And so I thought, okay, it's been used in people for decades, right? We know what the safety data looks like. I'm talking to a lot of people who are using it off label. It's plausible. I might as well give it a try. So I tried rapamycin. I took, I think it was 6 milligrams once a week for 10 weeks. And all I can say is the pain went away and I got 95% of my range of motion back. Could it have been placebo effect? It could have been, but just given how debilitating the condition was, I really don't think so. And the mechanism is so plausible that it just makes a lot of sense. It was probably the rapamycin. So since then, I've typically cycled rapamycin once every 3 or 6 months. I usually take it for 3 months at a time. And, I can't say that I've had that sort of profound outcome in any of the subsequent times that I've taken rapamycin or cycled rapamycin. I will say, and again, this could certainly be placebo effect. Every time I take it, or I should say, every time I'm off rapamycin for a few months, I notice a gradual increase in joint pain when I lift weights, wrists and elbows primarily. Every time I take it, that goes away. So again, take it for what it's worth. Could be placebo effect. To some extent, it doesn't matter, right? If you're getting benefit from it, you're getting benefit from it. Never had any real side effects. About 15% of people will get canker sores, and that comes from data we've collected from people using rapamycin off label. There's nothing else right now that looks statistically significant for a negative side effect associated with rapamycin. There are 4 or 5 things that came out of a survey-based study where people taking rapamycin had better outcomes than people who are not taking rapamycin. One of the more interesting ones has to do with severity of viral infections. So this study, I think, looked at 300 some people who'd taken rapamycin off label and 100 some who'd never taken rapamycin. And the data was collected, I think in 2022 to 2023, so pretty close to the end of the pandemic. So a lot of the people had been using rapamycin through the pandemic. No difference in risk of having a positive COVID-19 infection, right? So no difference in risk of infection, but the people who'd been using rapamycin off label throughout the period of their infection had a lower likelihood of severe outcomes, meaning hospitalization or having to go to the hospital, and a lower risk of long-term symptoms that could be long COVID, although long COVID, is hard to get a formal diagnosis of. So suggestive that there may be some protection against severe outcomes from viral infections. And there's other anecdotal data that would potentially support that. So again, we're sort of left in this situation where we have to just say, okay, that's a pretty plausible thing, given what we know about rapamycin and the biology. We can't be 100% certain, but when you start to see multiple lines of evidence coming from different directions or different studies, you start to get more confidence that some of these effects might be real.
It actually sounds very promising. And these results, because there are multiple options, you also have things like NMN and rapamycin. Like I said, do you think that's the future of lifespan, that we actually take a drug periodically or daily, and that will improve our lifespan?
I certainly think that is one of the things that should happen. Like, I definitely believe that there are small molecules that can supplement. I don't know if we have anything that's going to make up for a poor lifestyle right now. Theoretically, that's possible. I wouldn't suggest that rapamycin or any of the other things that are out there should be taken instead of a healthy lifestyle. But I do believe there are absolutely small molecules that can supplement lifestyle as a potent way to positively modulate the biology of aging. Certainly, that is doable in laboratory animals. We know how to do that in laboratory animals. The biology of aging seems to be very, very highly conserved. So I think it is extremely likely some of these molecules that work in laboratory animals will also work in people. How long it takes to get to the point where we are 100% confident, where we can say we've got clinical proof, that's a little bit of an unknown. For obvious reasons, it's difficult to do a lifespan study in people, right? In a clinical trial. So we are left with collecting data from a variety of different sources and approaches. There are now, many small clinical trials with rapamycin, things called senolytics. that target the biology of aging. Plasma exchange is another one. There are a variety of these interventions. So we might get data from multiple small clinical trials that, oh yeah, rapamycin works for ovarian failure, and it works for periodontal disease, and it works for vaccine response. And I think if you get 3 or 4 or 5 positive results from that sort of an approach, you can have a lot of confidence. The reason why it's probably working in all these other different age-related conditions is because it's affecting the biology of aging. But we're probably a long ways off from having a lifespan study, which would be the definitive answer. Now, you mentioned NMN. I'm careful not to put NMN or really any supplement right now in the same bucket as rapamycin, in part because the preclinical literature is nowhere near as strong, and in part because the dosing for supplements that people are taking is often way too low to have any real biological effect, right? So most natural products have pretty low bioavailability. And so even if they worked, it's not clear that the doses that are being sold to people would have the biological activity that you would want to have the positive effects. That doesn't mean that I don't believe that some supplements aren't going to work. I just don't think that we have enough information and that we can really trust the supplement industry enough to have confidence that the supplements that you would buy are actually going to be effective. And I can just give you a very specific example. So Brian Kennedy, a good friend of mine, the director of the Aging Center at National University Singapore, did a study where they looked at, I think it was 10 or 11 NMN supplements specifically. They just bought them from commercial suppliers, did mass spec to analyze what was in them. Most of the supplements either didn't have any NMN in them, or they had much, much lower levels of NMN than what was on the label. So there's the issue of, in a perfect world, would NMN work? That's a question. Then if it does work to target the biology of aging, is the bioavailability high enough at the label doses to have the effect you want? That's another question. And then, is it even NMN in the pill that you bought, right? So there are many levels of uncertainty here that make me really question the likelihood that you're going to get what you're hoping for from some of these supplements.
If I'm not mistaken, in general, you're not necessarily pro supplements. Is that correct?
Yeah, I would say I'm not anti-supplements. I think, so I'm confident in supplements where you can measure the level that you've got in your body and you know something about the optimal ranges and you can supplement into the optimal range. So those I feel very, very confident in. There's going to be things like vitamin D, omega-3, B12, things like that. You can measure, supplement, measure again, make sure you're where you want to be. When we get outside of that, then I'm a little bit more careful because, again, recognizing that there are systemic problems within the supplement industry, just in the quality of the supplements themselves. And there's not a lot of high quality data on efficacy for most supplements in people. So I tend to take a fairly conservative approach, especially to longevity supplements, because there's really little in the literature that has been reproducible for longevity benefits in animals when it comes to natural products, right? So NAD precursors are a good example. They've gotten a lot of attention. They've been promoted by, some high profile individuals. But when you actually look in the scientific literature, they have not reproducibly been found to increase lifespan or health span, even in laboratory animals. So there was one study that said lifespan extension, then other more rigorous approaches attempted to replicate that and failed. So I give specifics here. I'm being a little vague, but just to give specifics with nicotinamide riboside, so it's another NAD precursor, there was a study from Johan Alwerks's lab published in Science, reported lifespan extension. There were some pretty obvious problems with that study, including the fact that the mice were short-lived in the control group. So the lifespan extension brought the mice back to where they should have been. When it was tested in the very, very rigorous National Institutes of Aging Interventions Testing Program, no effect. So there are multiple examples like that where a supplement was reported to have positive benefits, and then when it was retested in a more rigorous way, did not show a lifespan benefit. Now, does that prove nicotinamide riboside can't have an effect on lifespan? It doesn't disprove the possibility, but I think you have to be skeptical that it is going to have a big effect if it had a negative result in the very, very best study that was ever done. So that's why I tend to not go overboard. And and, start recommending taking 10, 20, 30 supplements because they might have a benefit. I've heard people say, well, but they might have a benefit. So what's the downside, right? I think the downsides to taking 20, 30 supplements based on the possibility that they might have a benefit based on bad data, the potential downsides are, there's a couple of things I would think about. One is because of the problems with the supplement industry itself and some of the additives or impurities that can end up in these supplements, you're taking a bunch of supplements that can actually get to levels that could be problematic for your body. And we don't have any understanding of combinatorial interactions with supplements or small molecules, right? And so the idea that it's necessarily going to be a good thing when you start adding 10, 20, 30 things on top of each other seems naive to me. And the way I think about this is our bodies are really, really complicated machinery, right? One of the most complicated pieces of machinery you can probably imagine. You think of any piece of machinery out there and you go in, with a wrench or a screwdriver and you start randomly changing stuff, the likelihood you're going to make it function better is pretty low. It's much more likely you're going to make it function worse. And so if you start adding 10, 20, 30 molecules to your body, I think the likelihood it's going to end in a better outcome is less than the likelihood it's going to end in a worse outcome. The real likelihood is probably not going to have any effect. Most of these things don't have much bioavailability, but if it does have an effect, I think the risk reward probably tilts towards risk if you're just kind of adding a bunch of stuff that is weakly supported. So I tend to want to see a higher level of evidence before I'm going to start taking a supplement for myself personally, or at least a bunch of supplements.
And imagine someone is listening, they are living a healthy life, but they want to focus on longevity and they want to take something. Is it something off label? Is it a supplement? It doesn't matter. Yeah. Is there one thing that you could say they should take, or a few?
I don't think I think it's individual. I think it's individual. So the things that I would put on the short list, and these are the things that I put on my own short list, although I'm not taking, the only thing I'm taking right now, other than the kind of supplements we already talked about that you can measure, is rapamycin. And I'm doing that. I'm in my 3-month cycle. So the things I would think about, those could depend on your situation, right? So if you are under muscled, for example, and you're in your, again, woman or man, really, but for women, it's a different story because women obviously go through menopause and perimenopause. If you're under muscled and you have symptoms of hormone imbalance, I think that's not a supplement, but that's something I would get looked at, because a lot of people, every woman is going to experience this, and a lot of men experience hormone imbalance as we get older. And that can have a really negative impact on your metabolic homeostasis, your bone density, your ability to build and maintain muscle mass. So that's something you should get looked at. If you're pre-diabetic or diabetic, I would think about either metformin or a class of drugs called SGLT2 inhibitors. Metformin does not seem to be a true longevity drug. Again, there's a lot of misunderstanding and misinformation out there about metformin. It's similar to nicotinamide riboside when it has been tested in very rigorous ways. One example being the interventions testing program. It has not been found to promote longevity in laboratory animals, but it's a really good diabetes drug. SGLT2 inhibitors are interesting. They are a different class of diabetes drug. They have been found to promote longevity in laboratory animals. Again, is that going to work in people? We don't know, but at least it works in mice, and it's a really good choice for diabetes for some people, maybe also kidney disease. So I think it depends on, and so we could go down the list and talk about a bunch of different things, but I think it depends a little bit on your individual situation. So probably the best advice, and I wish I could, I'm working on it, but I can't yet give people the definitive way to do this, but probably the best advice would be to find a good doctor who is knowledgeable about this space, who can help you navigate for you individually what set of tests you need to get to figure out where you're at and what is going to be the best strategy, both in terms of lifestyle, potentially supplements, potentially seroprotective, small molecules, prescription medications, things like that. I think we'll get better. There aren't a lot of doctors out there that I have a ton of confidence in, but I'm needing more. And I think that is going to come where we'll have this sort of, next generation of really well-informed medical practitioners that can help people navigate this space. And that's really what you need.
And I think that's a movement in general, that we're going away from the general treatments and more to personalized treatments. And yeah, that's very
And
applicable in
proactive,
this.
right? Yeah.
Yeah.
Personalized and proactive, right? Not waiting until you're sick to do something about it.
Yeah. Yeah. We're almost out of time, but maybe a quick sidestep. A lot of your work actually focus on dogs. Why dogs?
Well, in part because I'm a dog person. I've always had dogs. And I, like many people, have always considered my pets to be part of my family. So that's very important to me. And I recognize the connection that we have with our companion animals. And this was probably more than 10 years ago now. A colleague of mine, Daniel Provislow, and Kate Creevy had started what was called the Canine Longevity Consortium. So this was a planning group to think about studying aging in dogs through observational studies. And so I was having many conversations with Daniel. We co-directed a course on the biology of aging at Woods Hole 2 summers together. And through that process, we talked a lot about dogs. And it immediately was obvious to me why an observational study of aging in dogs made a ton of sense. Dogs age 7 to 10 times faster than people do biologically, means we can study it in a much shorter time frame. And unlike, we talk a lot about mice and worms and flies, unlike those animals in the laboratory, our companion animals share our environment in almost every way, diet being the one maybe significant exception. So that's something we can't model in laboratory animals, but that's how our dogs live. And that's a really important aspect of aging. We talked about it. Somewhere between 50 and 75% of longevity is environment. So it gives the opportunity to understand not only what are the genetic components of healthy aging, what are the environmental components. So that was obvious to me, and I was in. But then it occurred to me, in sort of just thinking about this, that not only could we study aging in dogs, but and again, at that time, my lab was working on rapamycin and caloric restriction and a couple of other longevity interventions. And it occurred to me that some of these things are going to work in dogs. Like the biology of aging is so conserved, some of them are going to work. I don't know if it's going to be rapamycin or metformin or whatever molecule you're thinking of, but some of them are going to work. Maybe all of them are going to work. And oh my God, we could potentially increase the lifespan of my dog and everyone else's dog by 10, 20, 30% and Healthspan at the same time. That's something I have to do. So that was really the thought process. When I had that realization, I was like, okay, this has to happen. And so I immediately started working on how do we raise funds to test these things. And so the first thing that it made sense to test in my mind, and I think it was the right decision, with rapamycin. So that's kind of how that started. Now, it took 5 years really to get enough traction to do the sort of initial studies to convince people that this was feasible. I think everybody immediately got why it made sense. But I think, like any big idea, people were skeptical that we could actually build this thing and execute on it and do it. So it took really 5 years to get the first real grant to build this thing that became the Dog Aging Project. And so that's what we've been doing since then. Now a 50,000 dog plus longitudinal study of aging. We have the rapamycin clinical trial. It's ongoing. It was just finally refunded. So we'll get that finished up in the next few years. And then, we'll have an answer, at least for rapamycin. But I still think, even though it's taken a while to get here, it's important to say, we don't know if rapamycin is going to have the same effect in dogs as it does in mice. And there are lots of other things that can and should be tested in companion animals. I think as long as it's safe, and there's some reason to believe it could have a positive impact on health span or lifespan from laboratory studies, it should be a candidate for rigorous, randomized clinical trials in companion dogs, because we can get an answer in a few years if done properly. So I would like to see more of these kinds of studies in companion animals. I think on the positive side, we have now started to see companies, at least a couple of them, go down this path of trying to develop drugs, therapeutics, specifically for veterinary use, specifically going after FDA approval. And in some interesting news, a company called Trivium Vet, so they supply the rapamycin for our dog aging project rapamycin trial, just got what's called FDA conditional approval for rapamycin for cats with certain types of heart disease. And that comes directly from the studies in mice and some of our preliminary data in dogs, showing that rapamycin can have a positive impact on both age-related changes in heart function and also certain specific types of age-related heart disease. So really exciting, and I think a very positive development. I'm hopeful that we'll see more companies take that kind of a path.
The size of the study is already really impressive. And like you said, I can imagine you only want to test safe treatments because dogs are part of the family. I mean,
absolutely. Yes, it's very much, you have to think about it very much like you would a pediatric clinical trial, right? If you wouldn't test this in people's young children, you probably shouldn't be testing it in their companion animals.
Yeah, I totally agree. Do you already have some minor results you could share or not really?
Yeah, I mean, we've done 2 smaller scale clinical trials. One was 10 weeks, one was 6 months. They're both published, but the data's out there. So I think I can say with confidence, and so the larger one, which is 580 dogs, is still blinded. Okay, so I can't tell you anything from that study other than at this point, we have no reason to believe there are any serious adverse effects. Okay, because if there were, we would know that those have happened. So from the 2 studies that are completed and have been published, again, no evidence for side effects from rapamycin at the doses that are being tested. In both studies, we saw some evidence for improvements in heart function as measured by echocardiogram. They were different in the 2 studies. I don't know what that means in terms of the specific cardiac parameters where we saw positive changes, but in both studies, there was some evidence for positive changes. In the first one, it was pretty robust changes in what's called left ventricular function. So that's one of the chambers of the heart. We know that there's a decline in left ventricular function with age. 3 different labs, at least in mice, have shown in old mice, you can restore left ventricular function with rapamycin treatment. And so we saw evidence for that in the aged dogs. And then we also saw some evidence for increased activity. This was owner reported, so they weren't wearing quantitative activity trackers, but the owners were blinded. Again, it was really, I mean, it's a randomized double-blind placebo-controlled clinical trial. So the owners didn't know if their dog was getting rapamycin or not. At the time, they self-reported increases in activity. So that could mean, decreases in inflammation, decreases in pain. It's a little bit hard to know for sure, but that's what we know right now. So it seems to be well tolerated, really no evidence for side effects, and potentially some benefits in terms of heart function and activity.
That all sounds very promising. Matt, before we close off, do you have a take-home message for our listeners?
Yeah, I mean, I think one important thing, there's a couple of things that I would just reinforce, right? One is there is a biology of aging. And what I mean by that is there are biological processes that underlie what we think of as aging, right? And by understanding what those processes are, we can actually take steps to positively impact that biology to slow the aging process, potentially reverse aspects of aging. I certainly am not one of those people who talks about, reversing aging and making an old person young again. We can't do that yet, but we can have a significant impact. And I think one of the most exciting things that the science has taught us over the last couple of decades is it doesn't seem right now like there's a point of no return. And what I mean by that is pretty much wherever you're at, unless you already have a significantly progressed age-related disease, where the pathology of the disease is different now from the biological aging process, it doesn't seem like there's a point where you can't get benefit from improving your lifestyle and potentially as we develop these therapeutics from things like rapamycin or other drugs that target aging. So that's good news. And I think the important message is wherever you're at on your Healthspan trajectory, you can take steps to get on a better Healthspan trajectory. And you should think about that because I think most people in the United States, and this is probably true in many developed countries around the world, can get 15 years of added health span primarily through lifestyle change. And when you think about what could you do with 15 years of high quality life, just sit down and think about that for 5 minutes. That there's a lot of reason why you want to take steps to accomplish that. So think about it, go do it, recover your lost decades.
That's a really hopeful take-home message. Thank you. This was Apple French Pudding. I want to thank Matt Kaeberlein for the information. Let's meet again for the next episodes of Apple Finch Pudding.